All right, welcome again. So, welcome to another Sunday morning session. So, this is the term two, first session of term two, and it's great to see all of you back. Um, Meeting questions. Um, Ask questions in the chat, no? Ask questions in the chat. All right, so yes. So, in the last 21 sessions, I think we started mid-September last year, right? So, this is our third term. And if I was just looking at the topic, I've pretty much covered what is very, very important in terms of one, the selective school exam. We've covered a lot, all of algebra. We've covered surds. We did cover trigonometry, heaps of stuff, right? Now, this term, the plan is to start with measurements. So today we will start with measurements and and then we'll do probability as well, right? So I'll touch upon probability. Probability is a very, very deep subject in itself, and in no way I can do justice to probability in an hour or two, or maybe in 5 hours, right? So having said that, I will touch upon the basics. You all are pretty much year seven, year eight, year nines. I'm assuming some of you might be year six as well. So I'll touch upon probability later down the track, and then once we've finished it, then probably we'll do a lot of practice questions. Maybe that's what the aim is. But for now, let's kick off the session. It's 3 minutes past, and we've got fair amount of audience now, 27 of you here. So we'll kick off. I don't know if people who have joined in for the very first time, welcome, and people who have come in every session, you are welcome as well. Before we kick off, very simple rules of this session. Number one, if I may ask, not to spam the chat at all, right? That takes my distraction away, and hence the quality of my teaching goes down, right? So if I may ask you with folded hand request, please don't spam the chat. Chat is primarily used for you to answer questions. So whenever I ask you to, or in case you haven't understood, right? So make sure that you use the chat accordingly. The chat is quite a free flow, right? So at times you might have asked the question and I might not have seen it because it's gone up, scrolled up, right? So we have a WhatsApp group, a parents WhatsApp group, and there are students as well, right, in that now. So make use of WhatsApp group and to ask questions, right? We're going to learn parabolas. I can do parabolas. I can squeeze in one session on parabola if you like, right? Yeah, we can do that. Parabola is a very advanced topic. Uh, year advanced year nine, advanced year 10, right? So someone who's a year five, year six could go could bounce off them. But then I'll try to simplify it as we progress. Uh, all right, I will share my screen now, and we just get the ball rolling. All right, I hope you all are able to see my screen, right? All right, let's kick off parabolas. Oh, no, sorry, let's kick off measurements. My bad. All right, so I will be covering from a measurements perspective. I will be this topic is actually in your curriculum right from your foundation, right? Right from your year three, year four, year five, year six. It starts from there, right? but I'm not going to go down that, lower level. So I will be starting roughly at a point where I feel that basic nitty-gritties of what measurements are, but I'll still try to build as we go. And the goal is to make it slightly more challenging, right, as we progress down the track, as we normally do. All right. And technology issues can come in. So in case you stop hearing me, my Bluetooth trips over, uh, just let me know in the chat. In case my pen stops to work, I will fix it, right? Or in case my internet goes down, I will restart and come back into the session. So in case you're thrown out of the session, you please join back, right? So just uh, it could be anything, right? Technology is technology. All right, cool. Let's kick off. Measurements. So measurements means we are trying to measurement. We are trying to measure. How do we measure? How do we measure? And what do we measure? Let's start with very basic measurement, which is the length. It might feel elementary to you, but everything starts with foundation. Right? All right. Length. How do we measure length? We measure length in meters, kilometers, centimeters, millimeters, and so on. Right. But then these are like four basic units of measurements that we normally use. They are not in the order of their you know the size, right? So obviously, if I have to order them, kilometers, then meters, then centimeters, then millimeters. So obviously, with inequality like this. Two people in the waiting room, so let me just get them in. Sorry about that. Get them in. Admit. All right. Now, how are we measuring? What is the size? The size is kilometers. So you've got kilometers. So 1 kilometer's got 1,000 meters. 1 meter has got 100 centimeters, and 1 centimeter's got 10 millimeters. So what it essentially means is, if we have something like this, so if we have to convert kilometers into meters, you multiply it by 1,000. If you want to convert meters into centimeters, you times it by 100. If you want to convert centimeters into, sorry, this is millimeters, you times it by 10. And so whenever you're going from higher to lower unit, you always multiply. And when you are going from lower to higher, you divide. So that means if you're converting meters to kilometers, you divide by 100. If you're converting kilometers to meters, you're timesing it by 100. As simple as that, right? Now, if I have to convert, and give me a second, I need to stop disable annotation. All right. Now, if I have to, just a quick, based on this, just a quick exercise, I know you should be able to do it. If I ask you, convert 36,000 millimeters meters, can you quickly do it? Now, I'm going from lower to higher, lower to higher. So lower to higher, lower to higher means you are dividing. 36 meters is absolutely right answer. Good job. If I change the color of my pen, so we had 36,000 here. I need to go to centimeters first, so I divide it by 10. So it makes it 3600 centimeters. From centimeters to meters, I have to divide it by 100. So 3600 divided by 100 makes it 36. Good job. Simple. Right. All right. Cool. Let's move forward. So this was the basic conversion, sort of a table of, if it's a table of conversion cycle, right? Now, where do we apply this? The very basic application of measurement is perimeter. Perimeter is measuring the boundary, measuring the boundary. So if you've got a four-sided figure like this, and I've got A and this, these are the lengths of each side of this quadrilateral. We did learn geometry, right? So four-sided figure is quadrilateral. And what quadrilateral is this? If I just throw that on you, what quadrilateral is this? Can someone tell me that I've just drawn in here? Thus says trapezoid, trapezium, trapezoid. Yeah, they are all good, good. Yes, this is a trapezium. How do we know this is a trapezium? I've got two parallel sides, and so two sides are parallel. So that makes it a four-sided figure. Where two sides are parallel, only two sides are parallel. Makes it a trapezium. Good. All right. Now, coming back, perimeter is just the measurement. So if I add A plus B plus C plus D is the perimeter of this trapezium. Very, very simple. Perimeter is given a different name when it is a circle. Let's say I have a circle with radius R. So the perimeter of the circle is called circumference. You all know that. The short form of circumference that I use is a dot and a CE on top. That's my way of writing it. Get used to it, right? Not many teachers use it. So circumference. And what is the circumference formula? It is 2 times pi r. Now, it is also pi times d. The d is the diameter. Diameter is 2 times the radius. Remember that. So circumference of a circle is the perimeter of the circle. Now, before we really deep dive into doing some questions, I would like to talk about something called composite shapes. What is a composite shapes? What is a composite shape? A composite shape is exactly when you join two shapes together. Good job. So when different shapes come together, not just two, when different shapes come together, most of the time two, yes, you're right. When uh, when when different shape come together and make an irregular kind of shape, but then you can still break them down into regular shapes. Regular shapes are what? Your triangle, your circle, your rectangle, your square. Those are regular shapes, right? So for example, if I have something like this, so this might not be the right. This is a composite shape. Why? Because it is made up of a semicircle here, a semicircle here, and maybe a square here. So this is an example of composite shape. Another composite shape could be, try to draw. Could be this. You can take this off. Oops. Is this. So here you have a, a square in the red, square in the red, and if I change the color, maybe two semicircles, equal semicircles. Assume they are equal. Two semicircles, semicircle one, semicircle two, which eventually means you've got a circle. So this shape is circle plus a square. I haven't asked anyone to write anything on the chat. I'm keeping an eye in case anyone's found spamming. It will be sent back to the waiting room. It's a very polite request, right? People have been pushed in past. I'll continue to do that. All right. Now, coming back to composite shapes, let's try to find the perimeter of these composite shapes. Mind you, perimeter of a regular shape, which is a non-circle, is just adding all of their sides. And especially for circle, it is pi d or 2 pi r, right? Keep that in mind. And let me just, snippy something for you. Yeah. All right. Can you find me the perimeter of this shape starting now? No calculators. No calculators. The pi is 3.14, right? Or you can just answer in pi as well. Don't use 3.1. You can give me in pi as well. I'm waiting for the answer yet. So someone said 40 plus the two people in the waiting room. So some 42 plus 20 pi. Nah, doesn't sound right to me. Doesn't sound right to me. I'm still waiting for the right answer. Who can give me the perimeter of this? Could be. Let's see. I might be mistaken. Early morning. Keep going. I'm waiting. There are quite a few people here. I need the answers, right, from everyone. Okay. Uh, I think I have seen the right answer. Good. All right, let's quickly do it. How do we do this? So we have a square. Just change the color. This is a square. No, not square. This is a rectangle. This rectangle is 21 here, 21 here, 20 here, 20 here. So I have to eliminate. I just measure the 21, 21 here. So 21 plus 21. That measures maybe the lines that I've marked as red. And then I need to measure this. These two are equal. Maybe I change the color. This, the green one, are equal. And this is a semicircle with diameter as 20. So pi d plus pi d, which should cover the circle. Or should I say pi d over 2 plus pi d over 2, which covers both the semicircles. And now d is, so this becomes 42. This becomes 42. And pi times, what is the diameter here? 20 over 2 plus pi times 20 over 2. So essentially, this now becomes 42 plus 10 pi plus 10 pi, which is 42 plus 20 pi. That is the answer. Now, Arav has asked me, how is diameter 20? Look at this, Arav. Let's look at the question again. This is the diameter of the semicircle, right? Let's change the color again. Right? This is the diameter of the circle, which is 20, right? All right, cool. All right, see, I tell you one thing, dealing the composite shapes is very challenging. Not very, it is slightly challenging in comparison to when you're given a straightforward. All right, let's try maybe another one. Let's give it a go. Right. Zoom it a bit. Nah, that's too much zoom. All right, let's try this now. This one's cool. All right, here you go. Yep. Now you've got a triangle. Go for it. Take your time. As soon as you have an answer, please throw it in the chat. Sehet says 480. Tanshika says 480. Niravi is 480. Okay, Darsh is converted into a centimeter. And it says 42. Abir, 480. There's nothing called 480, my dear boy. It is 480 millimeters. Don't forget to put the units. I'm doing perimeter. Shadow, I've not talked about area. Concentrate. I think the concentration needs to be here rather than the chat, please. Everyone. This is for everyone. 480 is the right answer. Good job. Now, how on earth this is 480? Let's quickly understand that. Let's take a red color. This line, this cut across every side of the figure just tells me that sides are equal. I told you when we were doing geometry. So which essentially means I don't really have to break down this figure into a square and a triangle. I don't have to do that. I'll save my time. I'll say every side is 80. Every side is 80. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 6 times 80 is 480 mm. You don't even have to break this down. Okay? If you've broken this down, you might have sort of taken a little extra time. Let's try one more. Let's try this now. Go for it. Give me in pies. Incorrect. Yes, so I told you to give me in pi. All right, yeah. So 9, 1. So the answer is 198 plus 66 pi centimeters. Good job. Right answer, Bir. 198 centimeters. It's not 198 centimeters. It's not 62 pi divided by 2. No. Yes, it is 198. Okay. All right. All right. Yeah. Let's quickly do it. Let's quickly do it. This is 99. So 99. So this is 99 as well. So another 99. Now I'll change the color. I need this. The diameter of the circle is 66. So this part is pi times 66 over 2. Pi d over 2. Similarly, this green marking that I've just done is also the same semicircle, exactly the same length. Why? Because their diameters are same. So another pi times 66, 2. So this eventually becomes 198 plus 66 pi centimeters. I've seen a lot of you have just given the answer this without units. Obviously, your selective school exam will not really care about the units because they are multiple choice. But people who really want to learn and improve right down the track is the units are very important. Please don't forget to write the units when you're doing it in your school exams. Also, I've seen someone, in fact, a few, have written it 198 centimeters plus 66 pi. Hang on. Why is this centimeters and not this? This is also a number, right? If you multiply it with 3.14. So this doesn't work. So that's the best. The way you have to write it down is this. Or, even more cleanly, I think I like the way Shadow has done it. So he's done 198 plus 66 pi within a bracket. I love the brackets, I tell you. When you put the brackets in, it becomes a lot more cleaner. A lot more cleaner. That doesn't mean that if you haven't put the brackets is incorrect, but brackets is the religious way of writing the answer. Okay, good job. All right, good attempt, everyone. Now, throwing another composite figure. Please concentrate before you attempt this. I'm going to zoom a bit so that you can see it. Go for it. Take your time before you give me the answer. Eight meters, 8 meters. Sakita, how is it 324.8? No, incorrect. 800 centimeters is obviously 8 meters. Good. 8 meters is the right answer. I still want you to do it. Anyone who's not done that, please do it. Good. 8 meters. 800 centimeters or 8 meters. Right answer. Good. Now, what we're doing here. Good, Darsh, yes, 8 meters. What we're doing here, we are saying wherever this line up, they're all 0.6, 0.6, 0.6, 0.6, 0.6, 0.6, and a 0.6. And then you've got this is as well as 0.6. This is 160. This is 160 centimeters. They're meters. The only thing that you need to be taking care of is the meters. So 160 centimeters, you convert into meters, is what? 1.6 meters, right? Add all of them, you get the answers in meters. Or convert 0.6 into centimeters, and you get your answer. I hope everyone's clear with this, right? No dramas, correct? All right. Let's do another challenge. Let's pop more circles in it. Circles make it a bit more twistier, right? Got people still joining in after half an hour, 35 minutes. Good that you're joining in at least. That shows some enthusiasm. Let's quickly do this question. Yeah, we can do this one. All right, here you go. Another one. My sessions are not YouTube videos. You need to do a lot. Go for it. Now, give me the perimeter in pies. And don't forget to add the units in the end. We'll do it, don't worry. Give me in simplified form, kinetic. If you're giving me in fractions, give me at least the simplified fraction. 40 pi is incorrect, kinetic. 40 pi centimeters is the right answer. Don't forget to place the units. 40 pi is the right answer. Now, how do we do it? It's very, very simple. Again, you've got 4 semicircles. Semicircle 1, semicircle 1, semicircle 2, semicircle 3, semicircle 4. And every semicircle has the same diameter, 20, 20, 20, 20. The two lines, these two lines tell me that they are the same. If I draw one line or two lines, geometry allows me to do it. Right? There's no rule behind it. So 4 semicircle means 4 times pi times d, diameter is 20, divided by 2, which gives you 40 pi centimeters. Good. Let's get the ball rolling to something which is even more interesting. Another shape coming to you now. There you go. Take your time before you attempt this. Perimeter. We are all doing perimeter. There's no area yet. I haven't touched upon area. Concentrate. Give me the simplified answer in terms of pi. Don't worry, we'll do it. We'll do it. That's the whole idea of it. Kinetic. This is the right answer. Good job. Not 17 pi. What is 17 centimeter pi? There's nothing called 17 centimeter pi. It has to be 17 pi centimeters. Centimeters after. The units are in the end. But then that's not the right answer. 17 pi is not the right answer. No, 8 pi is not the right answer. We are finding perimeter, Arav Kapoor. Perimeter. 16 pi is not the right answer. Okay, let's quickly do it. A lot of you have given the right answer. Don't worry, Kush, we'll do it. We'll do it now. All right. How are we going to attempt this? Always remember one thing. Whenever you are asked to find the perimeter of a composite shape, which means a shape which is a mix of a lot of shapes. Always you need to measure that side which is a darker line, not the dotted line. So in here, the measurement that I need to find is the one that I am highlighting now. So I need to measure this bit. So it is something like this, right? If I really not too great in maybe a shape like this. This is a shape like this. Okay. Now, please don't do the mistake of measuring this because this is just shown to give you some hint. That's about it, right? So this is not required. Now, let me just take this away. All right. Now, the red one is with what we are measuring. All right. So let's maybe I take this off as well, and we do it in 3 different colors. We do the red one. Let's measure this, the green one. So let's measure this, the green one. This is a semicircle, which means pi d divided by 2. Pi d divided by 2. What is the d? Now, the d here is the diameter, or if radius is given to you, you can chuck in a radius, right? Which is 2 pi r over 2 or pi r. Semicircle, the best way to find the circumference of a semicircle is pi r. Because the full circumference is 2 pi r. If I'm finding the circumference of a semicircle, it's divided by 2, which means pi r. So rather than saying pi d by 2 and making it more complex, I simply say this is pi r, and I know the radius as well. So this is nothing but 8.5 pi. 8.5 pi. Similarly here, this way, they're exactly the same, 8.5. We've got 8.5 pi here. So I have now measured the two green ones, the semicircles, right? So they are 8.5 pi plus 8.5 pi, which is 17 pi. One thing that a few of you forgot was measuring this bit as well, and this bit. They are 8.5 each. So you add 8.5 plus 8.5. So eventually this becomes 17 centimeters. And yes, 70 point whatever. Now you can plug it in. Kush, a call out to you. Did you understand that now? And anyone else who said that, we did not understand. Everyone's fine. I need to see a yes or a no, please, on the chat quickly. We're in the last 15 minutes of the session. Awesome. Cool. Good job. Let's move to, I've got 15 minutes still. It's a lot of time. Let's move to another figure. Probably I want to do area as well, but maybe area is too less a time now. Let's do more. Let's keep this session hands-on, right? First week back. That gets your brain and your hands both warmed up. Let's try this one now. Give it a go, please. Take your time. and give it a go. Nirvi says 120 plus 40 pi. Okay. 120 plus 40 pi. Centimeters or meters. What is the unit? Are we saying what? Centimeters? Nirvi? Are you sure? 120 plus 40 pi is meters is the right answer. Good. Good. How are we doing it? Let's quickly do it. Right. For those of you who haven't been able to do. Uh, so we've got red. We've got two semicircles marked in red. Now two semicircles make it a circle, right? So you can add, you can still say, yeah, there's one circle if the diameter is same. In this case, the diameter is same. I'll still go, you know, measuring each semicircle separately. So I told you the perimeter of or the circumference of a semicircle is pi r or pi d over 2, whatever you want to do. Radius is 20, half of it, so 20 pi. Similarly here, a 20 pi here, right? And then I'm measuring this is 60, this is 60, plus 60 plus 60 makes it 120 plus 40 pi meters. Simple, right? No dramas there. Okay. Let's do one more. Let's do one more. Let's see how you do this one now. All right, here you go. Can you find me the perimeter of this triangle? Twelve. Yes, we're using Pythagoras theorem. Exactly right. We're using Pythagoras theorem here. It is 12 meters, the job. Now, I need to know the hypotenuse. And this is a Pythagorean triad, a triad. 3, 4, 5. So this should be 5. Or if you don't know the triads, so I can simply say c square equals to a square plus b square. This is a and this is b and this is c. So my c square is 3 square plus 4 square, which essentially means this is 9 plus 16, and c is the square root of 25 makes it a 5. And then you just add them. Then you just add them. Yes, 5 meters is the, let me just add them. And so 3 plus 4, 5, exit. Simple. All right. Let us do maybe one more. Probably, we've got 8 minutes. I'm going to give you something now which is slightly lengthier, right? It takes a bit of a concentration for you to do it. And hence it'll take time. Might take over 8 minutes. If the time is up, I will still send the answer of this challenge that I'm going to throw now in the WhatsApp group. So for you to validate your answer. So in case you're not a part of, in case your parents are not a part of the WhatsApp group, just ask them to send me a message and I'll add them. And I'm more than welcome to hear those answers on the WhatsApp group. That's the prime purpose. All right. So what I'm going to paste now here is a netball court. A netball court. And this is how that netball court looks like. Now, before you jump in, just listen what are we trying to achieve here? Yes, it might make you laugh. All right, so I want to repaint all the lines. I want to repaint all the lines of this netball court. And all measurements are given to you. Now, what you need to tell me is what is the total length that I need to paint? Total length of lines that I need to paint. My session technically ends here, but your brainstorming should not, right? So think about it, right? It is very easy. Just break this down into various shapes. I'll give you a hint, right? There are semicircles, there are full circles, there are rectangles, triangles. I can quickly give you, and I would expect you to give me answer in pi, right? Or probably once you've got the answer in pi, better use pi as 3.14 and give me the final answer in decimal if you really want to, right? And then we'll see how we go, right? So, but before you start doing it, and in case this looks slightly daunting, I'll let you know what this is, right? So what you're trying to do here, this is a semicircle. So you need this semicircle. You need this semicircle. You need this one, a rectangle, maybe a rectangle here. And maybe change the color. Colors, I tell you. These two lines and this circle. Right. If you can give me, and I think someone's cracked it. Sakita, I loved it. By the time I was explaining, you just killed it. 155.62. The only thing that you missed, Sagita, was meters. And 155.62. Good. Good. You cracked it, right? You cracked the code. Give me in Abir, multiply pi with 3.14. Give me the final answer. The final answer is 155.62 meters. That's not difficult. That wasn't difficult at all. Has everyone got how to deal with this problem? Right? Yes. So you are, yes, right. 152.62 is the right answer. Good. You need to find this rectangle, the bigger one, two semicircles, these two extra lines, and the circle inside. That's about it. All right, I can quickly write it down if you. This semicircle here. What is the measurement of the semicircle? The outside boundary is the radius is 4.9. So the radius is 4.9 here too. These are equal. So pi times 4.9, and similarly for this one, plus pi times 4.9. Then I've got this bigger rectangle, 30.5 and 15.5. So I have another maybe 30.5 plus 15.25. And these two lines here, I just take everything off for a second. Yeah, these two lines here, they are also 15.25. So I add them as well. Another 15.25 plus another 15.25. What is left? Just this circle inside, which is the full circle. 2 pi r, 2 times pi times r, or maybe I say pi d. Pi times 0.9. And they're all in meters. If you calculate this, eventually you will get 155.62. All right, cool. That was pretty churny a session. I hope you found this useful. Next week, we are going to deep dive into area. And composite areas are, and I'm going to throw more challenge in terms of composite shapes, right? All right. Thank you very much, Shaban. I will, thank you for your appreciation. Yeah, I'll send it on Vagrant. Cool. All right. Thank you very much. And I will see you next week. And the recording of this session will be on YouTube. Goodbye. Enjoy the rest of your Sunday.